Okay, so this is the last section that we need to cover before the AP exam. They probably will not be testing you on this, but I still would feel more comfortable going over it just in case. Okay. The last section is volumes of solids with known cross sections. Now, the previous two volumes had to do with rotation around the axis. That's not going to be the case with this section. Okay. A cross section, if you look at these pictures, if you look through your handout and look at the pictures, we have two functions here, right? So here's f of x here. This is g of x. We can find the length between the two, so the area between two functions is f of x minus g of x, or g of x minus f of x, however you want to label it. But that same, if the cross-section is a square, then if you look at this picture, this height of the square is protruding out above it. And that height is the same length as f of x minus g of x as that base, because the cross-section is a square. Okay, so I'm hoping that makes sense. So let me repeat that again. If your cross-section is a square, here is the length of the base of the square. The height length, or the length of the height will be the same length as the base of that square. Okay. If we go through the other cross-section figures, these are known geometric figures. We have one for isosceles right triangles. So your base of your isosceles triangle is here. The height is right here, and your hypotenuse is this one. Now, notice with the cross-sections, the size differs as we go through the function. Okay. We also have equilateral triangles. We have semicircles. Now, these are just some geometric shapes. We can have other shapes that are possible and still be able to find cross-sections, and you'll do some practice with those in a little bit. Okay. Now, I'm going to start you off on the first one, and then I'm going to stop the video and have you do the cross sections for the isosceles right triangle, equilateral triangle, and semicircle. And then I'll come back and then do this one, finish it off. Okay. All right, so how do these work? We find the area of one of the cross-section figures first. Okay, so the square is really easy because f of x minus g of x is the length of the base. Your height is the same. So what is the area for this? Well, your area is just f of x minus g of x times f of x minus g of x, which makes it squared. Okay. Now, if all of these cross-section areas were added up, the total would be the volume of the solid pictured. How do we write this in calculus? Using an integral. So an integral from a to b of your cross-section, of your area, squared, d of x. That is your volume. Okay. So for each of the remaining figures, geometric figures, go ahead and find the area of the shape that's given using f of x and g of x. Then find me the integral to find the volume for the rest of the remaining ones. And then we'll go into the problem below.